Hello and good morning, everyone. Good Monday. I do want to spend just a little bit of time near the end of this video introducing module number 6. But before we go into module number 6, I wanted to take a moment to try and cover some stuff from module number 5, which some people kind of stumbled on just a little bit, which is perfectly understandable. We are slowly getting into the mindset of being able to make algorithms. Module 6 is going to focus, as we'll see, on thinking about problem solving in such a way that we can be on the right footing for making a algorithm into an actual program. And of course, Module 5 introduced some sort of key concepts about algorithms. And I don't want us to speed into Module 6 without talking about some of the things from Module 5. So, in particular, I wanted to look at Module 5, step number 3. Okay? So, it was interesting to me because each one of you, everyone who worked on step number 3 of Module 5, everyone who did this part, suggested and agreed that this was in fact an algorithm. Certainly it looks like an algorithm. It does step 1, step 2, step 3, all the way down through step 10. As you're looking closer, you'll see that step 7 has a decision, okay? And then we'll either repeat back up to step 5 or proceed to step 8. It looks like when we check that this decision will not always be true, so we won't always be looping back up to the top. We'll be eventually leaving. Okay, so as we look at the characteristics of algorithms, right? Well, what are those characteristics? Well, you'll remember from your required reading, not in the Xi book, but in the reading that was required to you outside of the Xi book, that the characteristics fall into 5 categories. We need to know about the input. We need to know about the output. We need to make sure that our instructions are definite, that they are effective, and that they are finite. Okay? Do we know about input and output? Well, we can make an argument either way. That's the thing about this. I kind of wanted to just start a discussion about if this makes up an algorithm. Okay? You all agreed that it did, but in so doing, you suggested that it must have then met the 5 characteristics of what an algorithm is. And no one kind of wanted to discuss about why this might not meet one or more of those characteristics. And I don't think it's exactly straightforward. I don't think it's as straightforward as you all are making it out. And I think that that is borne out by the fact that not only did you all agree that this was in fact an algorithm, but you all came up with different solutions. No two of you had the same solution. Okay, that doesn't bear well toward the idea that this is an algorithm. An algorithm should be executable and result in the same series of steps and the same output for everyone who executes the algorithm, okay, as long as they dutifully execute the algorithm. And the fact that all of you got different results, well, maybe this isn't an algorithm, or at least that's enough to give us pause, okay? So, those 5 characteristics, input, output. Do we know what the input is? Well, we know that we need to put a value 1 into the counter box, okay? Now, these instructions say to have a separate sheet of paper. I can't display a separate sheet of paper easily on when I'm doing a screen capture like this. So what I'll do is I'll just draw a box here, and you guys can imagine that I'm drawing on paper. And I call this box counter. Okay? Right? And the instructions tell me to put the value 1 in the box labeled counter. Okay? So that's what I'll do. Put 1 in counter. Now, that's on its own sheet of paper. So I would argue that this might represent the input to this problem. Okay? And another thing that might represent the input to this problem is that we are expressly told to create our own sort of reply here, our own, what's the word I use? Thread, I think. Yeah, so create a thread on the discussion to begin typing. Set your keyboard to caps lock. Okay, so I'll do that. On a sheet of paper, write down the word counter with a box below it. Did that. Put the value 1 in the box labeled counter. Okay, so this information is input. This is input, right? We're about to type more input into this box, in fact. Now, what about the output? Well, the output is not stated, okay? Now, we could argue perhaps that we know what the output is going to be by looking at this. It's going to be a series of X's followed by a yes, as long as this actually does terminate. But there's some discussion about this. We could have some discussion about this. It's not exactly clear up front with the description of this algorithm what the output would be expected to be, okay, or what we're trying to calculate, right? So there, you might make an argument that this is not an algorithm simply because of that notion that the output is not expressly listed in the statement here. Okay. All right. The third of the 5 characteristics is definiteness. I'm going to come back to that in just a second. So let's put a pin in that, and we'll come back to it. Effectiveness. Hard to say if this is effective or not because we don't know what we're calculating. Okay. We don't know what we're doing. Right? We don't know what this algorithm is supposed to do. So you might also argue that since we don't know what this algorithm is supposed to do, or what these series of steps are supposed to do, we can't speak to the effectiveness of the series of steps, and so maybe it's not an algorithm. One thing we can say for sure by sort of analyzing this series of steps is that if we add 1 to this value every time, then eventually counter, the value in the box counter, will not be less than 5. Okay? So, yeah, under those structures, this is a finite series of steps. It will not go on forever. Okay? Is it definite? What does this mean if counter is less than 5? Some of you, I think, understood my meaning when I said counter is less than 5. I meant the value called counter is less than 5. Some of you weren't sure what that meant. Okay? Now, this is actually a concept where we name a value, right? This would be called a variable, as we'll see in Module 7 next week. This would be called a variable. But you don't know that yet. So the fact that all of you ended up with different outputs seems to indicate that there is at least an argument to be made, right? That this is not a definite enough set of instructions, okay? That there is some ambiguity built into these instructions, which is interesting because I did not necessarily intend for there to be ambiguity built into these instructions, but it slipped in nonetheless, okay? Because this is what we'll come to know through our discussion in Module 6. This is pseudocode, okay? Maybe we could do things to make this code clearer. Maybe I could say, again, instead of counter is less than 5, maybe I could say if the value in the box labeled counter is less than 5, then go to step 5 and continue, right? Because I think some of you went to step 5 and then you said, well, no one told me to do step 6, so I stopped. Okay, and that's not what was intended, right? So let me work through what was intended. And I think I've made the point that we could argue that this is, in fact, not clear enough, either in its output or what we're trying to accomplish, or in the definiteness, the non-ambiguity, the unambiguity of the instructions. All 3 of those things we could argue that this fails to meet the standard of what an algorithm is. But here's what I intended nevertheless. So start down here. On your keyboard, type X counter times. Okay, so I did. Using the number currently in the counter box, that's 1. If counter is, so on your sheet of paper, change the counter value by adding 1 to it. Okay, so I'm going to change this. So this is going to become a 2 now. Okay, all right. Erase the old number, write down the updated number. Well, I can't erase using this technology, but imagine that I erased the number and just changed it to a 2. So if counter is less than 5, 2 is less than 5. Go to step 5. There we go. We're going to back up here. On your keyboard, type XX. XX. Okay? Why do XX? Well, it says type X counter times. Well, counter is 2, so XX. On your sheet of paper, change that value. Okay, change that value by updating it by 1. So now it's a 3. Okay. Go down here. We're going to find that it's still 3 is less than 5. Okay, so we're going to go back up to step 5, and we're going to type in X 3 times. Okay, then we're going to erase the value here. Okay, and now it's going to become 4. Okay. All right, so then we're going to, 4 is less than 5, so we're going to jump up here, and we're going to type in X 4 times. 1, 2, 3, 4. Okay. Then we're going to, on your sheet of paper, change that value by updating it. So 5. Okay. And now we're going to check to see, is 5, sorry, wrong button. Is 5 less than 5? No, it's not. Okay. So 5 is equal to 5, but 5 is not less than 5. So we do not go to step 5. Instead, we proceed to step 8. So this is what's called a decision. You might call it an if-else decision. One or the other of two things that you could possibly do. We'll see this pop up again in the programming module, maybe in module 6, but definitely in module 7. It's also a kind of way to implement a loop. Because you saw we went to step 7 and then we jumped back up to step 5 and repeated. Okay, but in this case 5 is not less than 5, so we do not go to step 5. Instead, we go to step 8. Step 8 says if you think this is an algorithm, type yes. Else, type the characteristic that does not hold. Okay, so I'm going to actually type in definiteness because I think maybe definiteness does not hold. You could have typed in yes. It's possible you think that this is definite enough, right? Then I'm going to stop typing, okay, and I'm going to submit the post. All right, and so that's roughly. Let me take this off here. Oops, wrong key again. Just a second. There. Yeah. Okay. There we go. Okay. So I'm actually going to do that to get rid of it. All right. So that's basically what I expected you to do. But of course, you all did it somewhat differently. Okay. So you can make an argument that this is in fact not an algorithm. One of the things we're going to talk about moving forward into Module 6 is that we need to be completely clear on what it is that we are doing when we turn a solution to a problem in our heads into a solution to a problem that the computer can understand. Now, as you get better at programming, right? As you get better at programming, it's not always necessary to have an intermediate step between I have this solution in my head to I'm going to now put that solution into code. So I'm going to move that from in my head to code. Okay? It's not always necessary to do that, but especially for beginning programmers, and just as a matter of good practice, it is sometimes useful to have an intermediary step between the idea in your head and the code that you write that implements that idea. And in Module 6, which is this week's module, we introduce two new ways, two intermediate steps to get from the solution we have in our head, make it clear, right? Make sure we have the five characteristics of an algorithm. We're clear about what the input is. We're clear about what the output is. We know that it is a definite series of steps that can be executed the same by anyone who reads it, right? That there's no confusion. We know it's effective because it always, no matter what the input is, gives us the expected output. That's what effectiveness means. And it's finite, which means that it does not go on forever. It eventually stops. Those five things are going to be necessary, and we're trying to prove by converting our mental model of how to solve this problem into a different model, an intermediate model of how to solve the problem, which can then be converted into a computer program. Okay, that's what we're doing. Now, those two types of ways, those two intermediate models that we're going to be looking at are pseudocode and flowcharts. Okay? And each one of those is just pseudocode is more like language, more like a series of steps. So the Module 5, Step 3 that we just looked at kind of counts as pseudocode. And flowchart is more of a visual understanding of what that intermediate step looks like. Okay, we want to make sure that we are meeting those five characteristics of an algorithm at each step. Though, we want to make sure that we are clear about what our input is, clear about what our output is, that we have no ambiguity on how to execute our steps, that we always get the right answer, effectiveness, and that the program always ends, finiteness. Okay. All right, so I wanted to mention that we will be reading Chapter 8 for this Module 6, okay, in the zyBooks, and you'll also see that there is some additional reading here. And in the interest of time, you may also have noted that there is no module pre-survey or post-survey, and there won't be either of those for either Module 7 or Module 8. Okay? All right, so we're gonna step away from doing pre and post surveys just in the interest of time for these last three modules. All right. So that's basically all I have for you in way of introduction to Module 6. I hope you have a good experience with Module 6. As always, you need to stay on schedule in terms of what's due. Module 6 is going to take this entire week. Module 7 is going to be jam-packed as we actually do the programming that we've been building up to, and that'll take a week and a half. And then Module 8 will take only a half week, and then we'll be done. Right? So it's been speedy, it's been fast. I thank you for staying on target with all of this. If you have questions, as ever, it's super important that you get those questions asked and answered, so you know how to reach out to me, and I'll be looking forward to hearing from you. Okay, have a good week.